Okay. Test 1, 2. We sounding good? All right. Hi, everyone. We're going to talk about Django and web development and secure web development. Is anyone here a web developer? Not a single one, huh? Is anyone here a web developer? Tinker, okay. So we're interested in web development with Django. Sorry, you probably can't see over my head. But first of all, what is Django? Django is the web framework for perfectionists with deadlines, and that is their official mantra. It's needless to say, it has a lot of batteries included. It's very easy to use, and it's actually really secure. It's not something they advertise as much as the ease of use standpoint, but it is great for security. It's an MVC, Model View Controller style framework. It's 100% built in Python. It's open source and has a really great community. DjangoCon and PyCon. There's a lot of Django people there. Very welcoming. Very great people. It's flexible and it's actually really fun to use too. So it's popular with startups and hobbyists. But it's also robust enough and mature enough to be used by the likes of Instagram, Pinterest, Discuss, Spotify. A lot of bigger companies use it as well. So, audience participation time. Everyone is probably either sleeping or a little bit buzzed by now. So here's my question. What is the most common web application security risk? Everyone in unison. Come on, nobody? Everyone in unison. Injection attacks? Right? Okay, Brett said it. Injection attack. So this is an OWASP number one, it's injection, whether it's SQL or code injection. I would have also accepted broken authentication session, cross-site scripting, or cross-site forgery. These are some things that Django actually does really well, and these are all in the OWASP top 10. Bonus points. What are a few more? Can anyone name a few more OWASP top 10? No? Security, misconfiguration, and missing function level access control. Now there's a few more OWASP top 10 that I'm not going to include here, but these are ones that Django actually is really good at. So we're going to use Django to power up our web application. Get ready for this. Nope, that didn't pick it up, did it? Oh well, I had some Mario sound effects in there. So Django, those first four that I have up there, injection attacks, broken authentication, cross-site scripting, and cross-site request forgery, Django handles completely out of the box. You don't have to do anything to turn those on. The other two, security misconfigurations and function level access, I mean, it is always up to the developer to do those, but Django has a lot of that built in as well. So the first one, injection attacks. Let's look at some code that might generate a SQL injection. I'm sure no one can probably read that, but you know, the old XKCD Bobby Tables comic, if you've ever seen that, you know, you can do select star from user where a username equals, and someone malicious adds, you know, dash dash quote drop all from user, etc. Or a code injection, someone enters something nasty in the email, and if you're a developer and you just grab that email field, you're injecting whatever code they put directly into your application. Let's try powering it up with Django. Nope, it's not going to work, is it? Okay. So we just powered up with Django. Our user input is still really nasty, but instead of doing raw SQL, we're just going to use the built-in Django. It's called the ORM, and it is used to retrieve information from the database, and something as simple as user.objects.get, username equals username. Doesn't matter if they put something nasty in there, Django's going to parse it out and make sure that it's safe. And that is the default way of accessing anything in Django. So you're already covered from SQL injection attacks right out of the box. Code injections, like I mentioned before with the email string. Django has forms that you can use. So you'll just create a form. You know, forms.email field, you'll add an email field to that form. When someone submits it, instead of grabbing the email field directly, you'll just say, make an email form out of the post data from that request, and you can just essentially run form.isValid, and it cleans everything, it checks if everything's valid, it's a ton of really great built-in stuff, and you can call, form.cleanData email, and it gives you that email fully parsed out, all the script tags removed, everything escaped, really good stuff. So you're protected from both code injection and SQL injections with Django right out of the box. Broken authentication. How many of you have seen any code that looks like this, where you're authenticating a user and you're saying, if password equals whatever they just put in, password 1, right? You see this all over the place. Clear text passwords, no hashing, no salting, one either two-way encryption or no encryption at all. Once again, let's power this up with Django. And Django includes an authentication middleware that right out of the box handles all of your authentication needs. It can even handle OAuth. There's some plugins that you can just plug in, essentially, some pip packages, and you get OAuth using the exact same code. No separate code needed to handle OAuth. But anyhow, you just call this Django authenticate function. You pass it the username, you pass it the password, that were both submitted from the user, and it will do extremely strong encryption. It's one-way encryption. I think it used to use B2Crypt. It uses something else now. But essentially, it just returns either the user or it returns null. So it's very easy to use, and it handles a really strong type of authentication. And like I said, if you are using OAuth, you call that exact same function, and it will just use the OAuth token to do, Gmail or Facebook or whatever you're using in the back end. So that's broken authentication. Cross-site scripting. This vulnerability is essentially if someone adds some JavaScript to the site, or if someone tries to tinker with the site, any sort of, HTML redirects or JavaScript or anything, they try and, it's sort of like a code injection, but not exactly. And, you can do this on a lot of websites, actually. You put some JavaScript in, you submit your form, and I'm picking on PHP here because it happens a lot in PHP if you don't escape it properly. You spit out whatever their username is, and their username is actually some kind of nasty JavaScript, and boom, your page blows up. Power it up, and Django, by default, anything that gets spit out in the template is escaped. All the strings get escaped. It will not show you any HTML. You'll just see the ugly JavaScript. It won't actually execute it. And there's nothing you even have to do to turn that on. It's just there. If you do want it to be HTML for some reason, if you're doing something with a CMS, or you have an HTML field or something, you have to turn on the ability to show the raw content using a special tag called safe. So by default, nothing will spit out HTML unless you tell it to specifically do that. And there is a middleware also for clickjacking, which is sort of related to this, that clickjacking is essentially having like hidden iframes or something on the site. A lot of ads actually do this, but if you have something on your site, maybe you're showing ads on your site, or you're showing some sort of external iframe content, someone tries to use that to clickjack, it won't work. There's a middleware that just completely blocks that. The last one we're going to talk about is cross-site request forgery. And essentially what that is say I have a domain called google.com spelled with 2 zeros, and I want you to sign in to g00gle.com with your Google account. Someone might not realize that, and they're just going to enter their username and password and try and submit it to actual Google, or they'll be on a site and try and submit it to some other site that maybe looks the same or is masquerading the same. That's what a cross-site request forgery is. So in a normal HTML form, it doesn't care. It will post anywhere, anywhere you tell it to post. Powering that one up, and there's one additional line of code that you need to add. It's a token called CRSF token, and Django by default does not allow anything to post to your site from a different site. And you have to have this token or else it will just reject it. So if you try and post anything, or if someone else tries to post something to your site's just going to, tell them basically, they're going to tell them where to go, essentially. So there's a middleware that handles that, CSRF middleware. Once again, this is all on by default. So if you just, if you install Django and you start a project, you're going to have all this stuff. You're not going to be able to have a cross-site forgery vulnerability on your site because this is built in and turned on by default. Oh, by the way, my little animations, I forgot to describe them here. Sorry, that's getting annoying. This is Django Pony. Django Pony is sort of an unofficial mascot, and the reason, it's kind of dumb, but yeah, it's funny, you know. The reason it came about was because, not that one. Whoops, I did something there. The reason it came about was from a talk with this magical powers, and someone was saying, you know, Django's, it's like a unicorn. It's got magical powers. So Django Pony was born out of that. And this one I just thought was funny because of the movie Django Unchained. He's riding a Django Pony there. Anyhow, a little bit of humor. Bonus round. Security misconfigurations, right? This is one that you can't really handle in the code. I mean, you know, you have to tweak the settings if you want to turn something on or off. But this code right here is directly out of a default Django. When you just install Django and you create a new Django project, it spits all this out. And it's got security warning comments actually in the code, and it tells you, do not turn this on in production. You know, it's really good about it. All these middlewares, there's a Django security middleware, cross-site forgery, request forgery middleware, all those ones that we just talked about, authentication middleware, they're all just turned on by default. So out of the box, debug is normally turned on by default because you kind of need that when you're developing. But, you know, there's a big bold warning above it that says turn it off. But everything else is, you know, it generates a secret key. It really has a lot of security settings on by default. And the other one is function level access control, right? This is, you know, especially if you're working on a big site, you might have thousands of different URLs or thousands of different endpoints. Special buttons, you know, if you work in an IT department, you know, you've probably created a special button that you gave to Jim in accounting to run a report that you hard-coded or something like that. You know, those things are all over the place, right? So how do you protect all those functions and keep them all under one unified blanket of permissions? Well, Django does have, they're called decorators, and it's just a one line that you add in front of any function or in front of any, you know, view or URL or anything that you make. The first one I'm going to highlight is called login required. You just add this, and bam, it goes through the full authentication process. If someone tries to hit it, it will give them the 403. It'll make them sign in. It'll, you know, it handles all of the authentication. Just one line of code, you add that, you know, it's great. Another one is staff member required. There's actually a bunch of these, but these are just a few that I picked out. Staff member required. Not only do you have to be logged in, but you have to have you have to be a super user, essentially. Permission required. This one's actually really robust because Django does come with its own entire permission system. And everything in your database at the table level, you can specify which user or which group should have access to that table. Read access, write access, etc. Change, you know, there's an access that you could say, they can create something, but they can't edit it. There's all these, those are all built in. So there's this permission required where you can just say, you know, say I have a table called secrets or a model called secrets, I can just, you know, say secrets.can update, which means that user who hits this, not only do they have to be logged in, not only do they have to be a staff member, but they also have to have the can update permission, or else it won't let them hit that function. And this last one here is called require post. That's just an HTTP. You know, if you get that URL, meaning you just go to it in your browser, it just won't work. You have to post to it. So if you're, you know, have a form or something like that. And if the user fulfills all of those requirements, then they will be able to hit that function. So function level access control, there's a ton of these. There's probably hundreds of them in Django. Everything from network restrictions, you can restrict host names, you can restrict user permissions, all kinds of stuff. So these are some really cool security features, right? But can I trust them? Can I trust the code that gives me these features? I'm getting really paranoid now. I'm going to put my tinfoil hat on. So keeping with the Mario theme, let's dive in and find out. the Django project security. So we're not talking about the security of the framework anymore. We're talking about the security of the people who make the framework. I'm really trying to sell you on Django, in case you didn't notice. Django's internal security, they have a dedicated security team. This is all open source, mind you, 100% open source, but there is a Django Software Foundation that funds most of the development. People donate to it. They raise money from conferences, etc. But they do have a dedicated security team. I think there might be like 20 more people or so on it. So it's not just one guy either. It's a very robust project. Excuse me. They frequently do security releases. Following the Python convention, there's 3 levels. The first, then the dot, and then the dot for security updates that are continually going. They also have a long-term support branch that they usually will support it for a couple years, and it gets all the security backports from the other branches. They have private and encrypted means of reporting a vulnerability. So if you discover a vulnerability in Django, or if someone else does, it is usually reported, not publicly available, through encrypted means. It is then verified and fixed by the developers. And I believe 2 weeks before that release comes out, they will then disclose it as like a CVE to the Common Vulnerability Database. So very, very strict security reporting procedures. They also have a lot of good documentation on their website about just how they report security issues, how they handle security issues. If you are building a Django project and you need to sell a client on it, or you need to pass some sort of security standard from your IT department, you can point them to this and be like, look, this is a really well-developed framework. They take security extremely seriously. They have all these processes in place. Like most of you would probably do that with AWS, or if you have a vendor, they submit, all of their vendors' own security reports or their security policies. Django has that available as well. And this I don't know for sure, but a lot of the core contributors like to brag about it, that Django, since its inception, 10 to 15 years ago, has only ever had a few actual critical vulnerabilities. There's a really strong code review and code quality process in place, but the community is still very welcoming. They're not assholes either. It's a very nice community, but they do have a strong quality control process before anything can get actually committed and merged into the main code base of Django, which is, not always the case with open source projects. So that's it. I'm not sure how my time is doing. I think we're probably a little bit early here, but thank you. My name's Vince Salvino. I'm with Code Red. Follow me on Twitter if you're into that. I don't really tweet that much, but any questions about Django or just web development or anything at all? Definitely. There are other frameworks, and actually a lot of these features, if you use .NET MVC, .NET MVC has a lot of these similar things. They have decorators. They have the SQL parameterization. That's not to say that Django necessarily does these better or it has more security features than other frameworks. It certainly does have more security features than a lot of frameworks out there, but it's all included out of the box. It's a fun and easy framework to use. And like I said, they really have the opt-out versus opt-in mentality to security. So I think for a beginner or for someone who is not very conscious of these security features, or if you don't have a dedicated security engineer working with your web developers, it's really great to be able to hand this to your web developers and say, you should try out this framework. It's got a lot of stuff out of the box and turned on by default to prevent you from creating insecure code. Yeah. Yeah. Yeah, no, there's a lot of frameworks that do this, but Django has been one. I've worked with WordPress a lot. Have very mixed opinions on that. PHP, PHP is a language. It's not really a framework, but people use it as a framework. And when you do that, you run the risk of not including all of this stuff. So, .NET is a completely different animal, but it does have a lot of the same features. Some of them you have to turn on by default or opt into, but yeah, there's a lot of good frameworks out there. But I think Django is up there with the best ones, at least based on my own usage.